Solar eclipses have long captivated humanity, evoking awe and, at times, fear. Throughout history, these celestial events have been associated with various natural disasters, from earthquakes to volcanic eruptions. But is there a scientific basis for these associations, or are they rooted in myth and coincidence? If you're intrigued by the mysteries of the cosmos and how they intertwine with Earth's phenomena, subscribe to Orbit Watchers. Join us as we delve into the fascinating relationship between solar eclipses and natural disasters. Historical perspectives on eclipses and disasters. Ancient civilizations often viewed solar eclipses as ominous signs. In the year 585 before the Common Era, a solar eclipse reportedly halted a battle between the Lydians and Medes, as both sides interpreted the sudden darkness as a divine signal to cease hostilities. Similarly, the Assyrian eclipse of 763 before the Common Era was recorded in cuneiform tablets, coinciding with periods of civil unrest and plagues. These historical accounts demonstrate how solar eclipses were often seen as harbingers of catastrophe or change. The cultural impact of these events was significant, frequently guiding major decisions by rulers and priests. From China to Mesoamerica, records of eclipses were meticulously kept, reinforcing the belief that celestial alignments influence terrestrial outcomes. Scientific investigations into eclipses and natural disasters. Modern science has sought to investigate the purported links between solar eclipses and natural disasters. One key area of study focuses on the ionospheric and meteorological responses to eclipses. Research analyzing the total solar eclipses of August 21st, 2017, March 20th, 2015, and August 1st, 2008, revealed that these events caused distinct changes in atmospheric conditions. Observers noted temporary drops in temperature, variations in wind patterns, and fluctuations in the ionosphere. Despite these temporary effects, there is no conclusive scientific evidence linking solar eclipses directly to natural disasters such as earthquakes or volcanic eruptions. The changes induced by an eclipse are brief and localized, insufficient in magnitude to cause tectonic shifts or eruptive activity in volcanoes. These findings highlight the importance of distinguishing coincidental timing from causation. Case studies examining eclipses and seismic activity. Reviewing specific cases where eclipses and seismic activity occurred close in time can shed light on potential correlations, though not necessarily causation. 2010 Chile earthquake and solar eclipse. On July 11, 2010, a total solar eclipse was visible over parts of Chile. Within several hours, a magnitude 6.2 earthquake struck the Antofagasta region. The close timing raised speculation, but subsequent scientific review found no causal connection between the eclipse and the seismic event. Chile lies on a tectonic boundary prone to regular seismic activity, making such coincidences statistically plausible. 2024 New York earthquake and upcoming eclipse. In April of 2024, a magnitude 4.8 earthquake occurred in New York, just days before a highly anticipated solar eclipse. Despite the proximity, the United States Geological Survey reported no relationship between the events. Eastern North America experiences minor seismic activity regularly, and the occurrence was deemed coincidental. 2009 Tonga earthquake and total eclipse. On July 22, 2009, a total solar eclipse swept across parts of Asia and the Pacific. Just over 1 week later, a powerful magnitude 7.8 earthquake struck off the coast of Tonga. Though some link the two events due to their close succession, seismologists emphasize that tectonic activity in the Tonga Trench is frequent and not influenced by astronomical alignments. 1999 Turkey earthquake and eclipse. On August 11, 1999, Europe experienced a total solar eclipse. Just 6 days later, a devastating magnitude 7.6 earthquake struck northwestern Turkey, killing thousands. Although the timing prompted public speculation, scientific analysis pointed to regional tectonic stress along the North Anatolian Fault as the true cause. No gravitational anomalies associated with the eclipse could account for the seismic energy release. These examples underline a critical principle in scientific investigation. Correlation does not imply causation. Even when two phenomena appear linked in time, rigorous analysis is necessary before drawing conclusions. Understanding the gravitational forces at play. The gravitational forces exerted by the moon and the sun do have tangible effects on Earth. These are most notably observed in ocean tides, with spring tides occurring during new and full moons due to the alignment of gravitational forces. During a solar eclipse, the sun and moon are in near perfect alignment, and their combined gravity can slightly enhance tidal forces. However, the concept that this gravitational alignment could trigger earthquakes or volcanic eruptions has not been supported by empirical data. A comprehensive study examining correlations between solar activity and global seismicity concluded that while solar phenomena influence the magnetosphere and upper atmosphere, they do not initiate tectonic activity. The Earth's crust is governed by plate tectonics and internal heat dynamics that operate on geological rather than astronomical timescales. Furthermore, during a solar eclipse, the gravitational conditions do not differ significantly from a typical new moon. Since new moons occur approximately once every lunar month, about 29.5 days, without corresponding spikes in seismic events, this suggests that the gravitational configuration during eclipses is insufficient to provoke natural disasters. While solar eclipses are awe-inspiring celestial events that do impact certain atmospheric variables, current scientific evidence does not support a direct causal relationship between eclipses and natural disasters such as earthquakes or volcanic eruptions. Historical associations and modern-day coincidences are compelling narratives but remain unsubstantiated when subjected to rigorous scientific analysis. It is essential to view solar eclipses through a lens of curiosity and wonder rather than fear. These rare alignments offer opportunities for scientific exploration, cultural reflection, and shared human experience. By embracing evidence-based understanding, we can appreciate the magnificence of an eclipse without succumbing to superstition or misinformation. We hope this exploration has provided clarity on the relationship between solar eclipses and natural disasters. Share your thoughts in the comments below and let us know which cosmic topics you'd like us to cover in future videos. Don't forget to like, share, and subscribe to Orbit Watchers for more insights into the wonders of our universe.